So the sustainability is the one topic that we are talking about, but as a part of it, we were talking about the transceivers that could be actually future-proof because they can be either reused in different active equipment while reprogrammed through SRD, or they are the future-proof design, like we said about the FR1s. But actually, we can be even more future-proof, right?
This is another topic we would like to bring today. Is really universal optical transceiver. This is the transceiver which could work today with the speed 10 gig. And this speed could be upgraded just by changing the operation mode to 25 gig with single click. So this is a solution which could be really useful for network operators. The huge advantage of this transceiver is not only changing the speed between 10 and 25 gig, it's also number of applications we could use this transceiver, because it could be used on single fiber, it could be used on dual fiber network, it could be used in the dark fiber solution as well as DWDM solution. It could work as a fixed DWDM, tunable DWDM, or auto-tunable DWDM. So the application we could use this transceiver, the number of applications is really huge.
Even more, it could work as a Ethernet transceiver, carrying the Ethernet traffic, but it could also work with CPRI and eCPRI protocols as a transceiver supplying the antennas of cellular network, especially when it could work in a wider temperature range related to even outside installation with extremely high or extremely low temperatures.
So which applications can benefit most with using the universal optical transceivers? On which applications that operators can benefit most of future-proof design?
I think that the really beneficial it will be to connect the base station, because
so the 5G
could be also deployed in the 5G, but because it supports also the lower speed, it could be also deployed still in the 4G networks. So it all depends what is the current status of the developing the network by the particular operator, and it could be used there dynamically. And even later we change the requirement for the higher bandwidth. We still could use the same transceiver, just changing the operation mode. I think that especially for the operators and many teams working on site and installing the new antenna spots, it's really important that this transceiver have this auto-tuning feature, because auto-tuning feature, the two most beneficial things of having such feature in the transceiver is, first of all, it's completely switch or device agnostic. It means that the device do not need to support DWDM transceiver, do not need to support the tuning features, because all the process of tuning the wavelength, the available wavelength, is done by the intelligence built in the transceiver. And the second benefit is that we do not need to provide the special training for the installation crew in terms of how to connect the DWDM transceiver, how to set the proper wavelength. Because from their point of view, they just connect the patch cord and all other job. So finding the proper channel is done by transceiver itself.
So we are talking about sustainability, so it's worth to mention that especially this type of transceiver makes very powerful combo with our SRD environment, because even
well, actually those two make this a universal solution.
Because we can use this transceiver even in the network devices which not supports generally the tunable transceivers, or we can program the mode mentioned by Marcin by SRD, not by functionality of the switch. So even if switch do not have functionality of automatic switch from 10 to 20G speed of transmission, we can program certain mode with SRD. And
so actually it increases the features of the network equipment, of the active network equipment. So devices that are not dedicated to work in DWDM networks can be used in DWDM networks.
Exactly. It makes a huge range of possible usage of this transceiver.
So the number of applications it could be used is, if we talk about the variation, it's really huge, because we have, first of all, the physical environment, which is, as mentioned previously, single fiber, dual fiber, DWDM network, dark fiber. We have also 4 different speeds available. And when adding the features of coding the transceiver for different vendor and fixing the particular speed and operating mode, if the particular vendor equipment do not support serving particular transceiver, it makes the really huge number of applications of just single transceiver.
So is it safe to use the universal optical transceiver in the different applications, one by one after another, after we exchange the equipment? What's the durability of this transceiver? How many years we can use it as operator?
MTBF of transceiver we offer is much longer than lifetime of network equipment, so we don't see any problem with exchanging the compatibility or mode, work mode of the transceiver if we can use it in different environments.
So it will work as good as new.
Yeah.
And we eliminated the wastes. We even generate even less e-waste, like you said. So this is another way to achieve the sustainability in the operators' networks, right?
Exactly.